You've probably noticed I'm not Tom. Tom was unable to make it, so I am tagging in, kind of a last-minute switch, so sorry, everyone. Anyway, so welcome to this morning's session on Services Assemble, or like I like to say, applying MVP principles, minimum viable product principles, to create cutting-edge microservices without chaos. And of course, we're going to be using Spring Cloud and Netflix OSS for that. My name is Mark Heckler. I'm a principal technologist and developer advocate with Pivotal. I blog semi-regularly at my personal domain, hecklers.org, not as often as I'd like. 2017, that's one of my resolutions, so we'll see how that goes. But I tweet very regularly at MKHeck. And I know several of you are on Twitter, right? You raised your hands yesterday. That's great. I kind of live on Twitter, sun up to sundown, and times in between. I have no life, it's true, as you'll see as we go throughout this session. But if you're not on Twitter, for whatever reason, I'm also a member of the slightly older and more established social network called email. So I am reachable by email. I'm just not quite as diligent about checking it. I'm on Twitter all the time. I'm on email periodically. So if you have any questions, comments, feedback, if I kind of brushed over something very quickly that you'd like to talk about more at length, maybe I would like to talk about it more at length as well, email me. That's fine. Or tweet. Tweet me, bro. So anyway, we have a very short amount of time here this morning. Tasha said that I could only have like 3 hours, so we're going to have to cut it down. Just kidding. I'm not going to stand between you and the next speaker or lunch. But I'm going to kind of optimistically launch out and see how much we can cover, and then get to wherever the hook comes out, and I'll stop. But I would ask that you hold questions to the end. Or more realistically, to this afternoon. I will be around this afternoon. I have to bolt out and come back really quickly, but I'll be here all afternoon. So if you want to talk about it, by all means, happy to talk about it. Or after that, that's fine, because the time here this morning is short. Time afterward is practically unlimited. So with that, let's launch in. So who am I? Well, I'm the author of several blogs and blog posts. I've co-authored one book. I have another in the pipeline. I have spoken around the world on various development-centered topics. I love Chicago. I'm actually, I maintain a home in St. Louis that I'm never there to see. But I call St. Louis home. As long as my wife picks me up at the airport and drops me off at the airport, it's still home. So always love a chance to come to Chicago. So thanks very much for inviting me. I am a developer, and as you might guess from the next point, most of my expertise is in Java. Recently inducted Java Champion just last year, so if you had anything to do with that, thank you very much. And as I say, I'm a survivor of many monoliths. I worked for Oracle for several years, and I was very acquainted with the monolithic model. And sometimes that comfort, even though sometimes that familiarity breeds comfort. Even though you know there are problems, you kind of know how to work around them. You know how to address them and deal with them. You know where the bodies are buried. So I was a reluctant convert to microservices, but I am a convert, unapologetic convert, as you'll see as we go through this, because I'm a seeker of a better way, like everyone else here. If you weren't, you wouldn't be here, right? That's enough for now. So this is what we're going to be talking about today, right? Microservices. I think this is a great illustration of what a microservices architecture is, and it's not just because I'm a geek, okay? But the sum of the whole is greater than the sum of the parts, right? If you tried to create one monolithic superhero, it probably wouldn't be all that interesting. It would be kind of cumbersome and awkward and clumsy. But here we bring together a lot of different characters with a lot of different strengths, and it really works, right? Is anyone a Marvel Comic Universe fan here? Please? Anybody? Okay, good. Good. I will say this. My wife tells me I'm unintentionally funny. So if I say something funny, you can almost be assured I didn't mean to. But if I do try to say something funny, and you can tell I'm trying to be funny, I do take pity laughs. Okay, so by all means, it makes the presentation go so much better. It makes me cry a lot less when it's done, so please. So, when you start considering a microservices-based architecture, you start to realize that the complexity goes up quite dramatically, quite quickly. Is anyone here a Netflix subscriber? Yeah, a couple of you. Okay, that's good. Netflix, I guess it was just last year. Yeah, maybe it was the end of the year before now. I'm kind of losing track. Went entirely cloud-based, entirely microservices-based across their entire platform for everything. Now, the Netflix.com site you're familiar with, that is all microservices driven. Does anyone care to guess how many microservices feed that single pane of glass? Those of you who've heard this before, you can't answer.
500?
Oh, come on, you've heard this before, right? All right, well, it is roughly 500. And that's a handful of microservices, right? And what do you think the odds are that any one of those microservices is only running one instance anywhere in the world at any given point in time? Probably pretty low, right? Because you're going to have multiple instances of each service running in different locations and providing that capability. So just for argument's sake, let's say that each of those has 10 instances running at any given point in time. So a little bit of quick math, that's 5,000 instances of microservices running. That's a lot to keep track of. So when you convert to a microservices architecture, when you embrace that architecture, you embrace a certain degree of complexity. I like to talk about the enablers that are required in order to deal with that. Typically, you have two kinds of enablers, and some things kind of do double duty. You need to have enablers that allow your microservices and enable your microservices to communicate, to interact, to interoperate. And that's great. But you also need enablers for what a colleague of mine likes to call the meatware, us. So we can reason about the entire system, so we can understand what's happening and how it's working and what's happening within things. So we're going to be talking a little bit about enablers today. We start with the foundation of Spring Boot and Spring Cloud, of course. Spring Boot, as it says, gets you from 0 to app in under 5 minutes. Spring Boot provides a lot of different capabilities for you that are very nice. I don't want to belabor this point, but I will at least mention a few things. It simplifies your dependency management. There's an auto configuration that makes sensible, reasonable assumptions based on your class path and annotations in your code in terms of what capabilities you want to provide for that microservice. And then you have Spring Cloud that provides some of those enablers to help everything work together as a whole. As it says, designed for fragile infrastructure, aka the internet, in partnership with Netflix. Because at any given point in time, there's a really good chance that one instance, or I should say several instances, of several of these microservices will become unavailable. Something will happen. They will fail. A server will fail. A network connection will fail. And hopefully you have a good cloud platform that will spin up a replacement instance. All of these instances are ephemeral, right? You need to have things that help them find each other. So that's where we'll start here. Pardon me, I have to de-mic and cough for a moment. Okay, yeah, now I'm going to start something. Sorry about that. I am getting a little warm, so I'm going to strip here. That's all part of the show, folks. You didn't realize what you were in for, did you? Okay. Okay, so here are some of the key components. This is not an exhaustive list, but it's kind of the high points. So in terms of the enablers that you would want, when you start dealing, well, okay, let me back up. When you have a monolith and you have certain configuration settings that you need to use for your monolith, you may have those embedded as magic strings in your code. And that's not great, but it is just one monolith after all. But when you convert to a microservices architecture, you start looking at a lot of different repeating instances. You need to somehow externalize that configuration and be able to manage it without introducing new bottlenecks, right? That's a problem. So we have Spring Cloud Config. Now, typically your configuration settings are what? They're key value pairs. They're key value pairs, and that's text. So we need to have some mechanism in place so that we can audit and version control and manage those. We do that all the time with code, right? What do we use for that? We use Git. Or maybe SVN or something else, but I mean, it's 2017, so Git. So Spring Cloud Config doesn't reinvent the wheel. It rests upon the repository, a Git repository, to provide a lot of those capabilities, and then it serves those settings up to any microservice that contacts them and identifies itself as needing config. Okay. All right, excellent. So I will go into more details as we go along. I think it's helpful and instructive to see that in action. So I won't go into a lot of details as we go down the path here, but I do want to at least provide a summary. When you have multiple instances of multiple microservices, they need some way to see and be seen. What we might refer to in the old days as a phone book. You know, way back in the day, and we're talking probably, what, 6, 8 years ago now? I mean, that's forever ago. When you go to a new city and you had a friend in that city, you would have to try to look them up and call them, right? So you'd find a silver box on a corner, street corner somewhere, and hopefully it would have a book hanging from this chain. If not, you'd go to another silver box. And you'd look up your friend's name, and you'd find a number, and you'd call your friend and say, hey, I'm here. And then you'd meet up, and so on and so forth. That's what's called a phone directory, really quaint. But your microservices need the same type of thing. If an instance of microservice A dies here, and your cloud platform spins up another instance here, it has to be searchable, locatable by consuming microservices. That's what's called a service registry. Netflix has Eureka. There are other things like Console, which actually also is a key value registry as well. But I talk primarily about Eureka because it's an excellent entry in the field. And we incorporate that into Spring Cloud OS as well. I'll show you that as we go also. Typically, you need some form of circuit breaker as well. In your house, if you have a wiring problem in your master bedroom, you may lose power to your master bedroom. A circuit breaker may trip. Or if it's really bad, you may lose power to your house, but you don't lose your house. That's the value of a circuit breaker. So Netflix implemented Netflix Hystrix. Hystrix allows you to gracefully degrade. And you can nest these, by the way. You can nest and have multiple fallback methods. So it can be turtles all the way down. I'll show you a fairly simple example of that, but again, your imagination kind of is your limit on that. But that allows you to gracefully degrade and provide meaningful capabilities to your end users or to consuming services. So for instance, on the Netflix.com site, if there's anything wrong with the recommendation engine, if for whatever reason that application can't reach the recommendation engine, you may not see recommendations for you in that central bar. But you'll never see an empty bar, will you? What you typically will see is popular in your area or something like that. It gracefully degrades, it steps down. You may not even notice when that happens, although it is fairly rare. But when it happens, it's still providing some value, just at a lesser level, until things can be restored, until things can heal. That's the other value of a circuit breaker, because in a monolithic world, what happens when the monolith goes down? Demand builds up, right? And then when it comes back online, all that demand slams into the monolith. With a properly implemented circuit breaker, it allows time for that circuit to heal. So typically it's either a closed state, an open state, or a half-open state. And once some connectivity is restored, periodically, Hystrix will allow a connection to be tested. And of course, once that succeeds, it doesn't just slam it with traffic. It gradually restores that traffic and allows that circuit to come back online in an orderly fashion. Then you have things like load balancer. Netflix Ribbon is a client-side load balancer, so you don't, again, introduce new single points of failure in your communication structure. Zool provides intelligent routing. Is anybody familiar with Hittite mythology? Zool? No? Ghostbusters? Okay, well, that's a start. Okay, so that's a reading assignment. But anyway, Zool is the gatekeeper to the underworld. Actually, in this context, what it is an intelligent external routing capability. So you don't have to embed routing information in your applications. Because what happens when a backing service goes offline? If you have to modify the consuming microservices code, rebuild, retest, redeploy, that's very time consuming, right? Probably not a best practice. So if you externalize that routing, that gives you the ability to change that routing information without taking your systems offline. Very useful, very helpful. It also factors into this whole, the whole pattern of strangling the monolith, if anyone's grappling with that. Zool is an excellent capability or additional component in making that happen. Then you have things like asynchronous message, which Spring Cloud Stream provides, and distributed tracing, as provided by Spring Cloud Sleuth and Zipkin. Zipkin was a project that Twitter created based on Google's Dapper papers. Say that 3 times fast. So Zipkin is a really great tool. We actually have Adrian F. Cole from Twitter. We hired him. He now works for Pivotal and is working full-time on bolstering and improving Zipkin and Sleuth, and that's coming along pretty nicely as well. So, and then of course security ties it all together, and much, much, much more. We don't have time for the much more. We probably don't have time for all of this, but we're going to launch in and again see how far we can get. So let's smash this, right? Before we do that, I do want to show this because I never remember to put this up until like I'm pulling the Mac off the stage. But here are some helpful links. We have start with the Spring I/O guides. A lot of times folks ask, how can I get started with something? Even if I kind of have an idea, but I'm not sure how easy it would be to implement or where I need to start. The guides, there are a few really in-depth treatments of topics, but by and large, the guides are kind of bite-sized nuggets, maybe 15 or 20-minute run-throughs. You can pull down the code from GitHub. You can code it all yourself. It steps you through all of it. So that's a great place to start. I also like to point to the code for Spring Boot and Spring Cloud. I always tell people, pull down the bits, play with them, if you haven't already. Also pull down the code. I mean, it's all open source. It's all out there on GitHub. And if you have change requests or anything like that, that's fine. If you're trying to work with something and it doesn't respond or act like you think it should, ask a question. We're on Getter. And perhaps you're not using it right. Perhaps you are and it's not working right. All that's valuable feedback. And if for some reason it is a gap, maybe it's already being worked on, or maybe it isn't. And if it isn't, we take pull requests. So just keep that in mind. But do ask first in case it's already in the pipeline, because there's nothing worse than spending a whole weekend on something and getting a pull request rejected because it's already being incorporated. So, and finally, of course, everything that I show today and more is linked from this meta repository at the bottom. So that's a great starting point. So I will pop out of here, and we'll switch over to Mirror. And cough. OK, so let's see. Let's mirror the displays. OK, so we're good there. Let's blow this up. Ah, that's much better. OK, so that's actually readable. I'm going to take a quick drink. Don't have a lot of time to go into the Spring Initializer. We talked about that a little bit yesterday afternoon, but we can talk about it more this afternoon if you'd like. But that's kind of the start of your microservices journey when you're developing Spring Boot and Spring Cloud microservices. We're going to start with the config server. There are different ways you can approach and anchor your microservices architecture. I like to start there because I like to pull everything from my config service. So that's where we'll go today. I'm going to create a config service. By the way, I do want to tell you that I get to typing really fast, and I kind of get on a tear. So I will occasionally insert typos in my code just to see if you're all paying attention, OK? And if a typo slips through and I get a build error, it's on you, front row, OK? So this is, keep sharp eyes, all right? No, I'm kidding. I actually do get going kind of fast, and brain goes faster than fingers, and sometimes that's a recipe for disaster. So. OK, so I'm going to bring in the dependency for a config server, and that's it. So let's go ahead and create that. I'm going to just dump this on my desktop, and we'll open that up. New desktop, open, and we'll open that in our favorite IDE. I don't want to start any wars here. I like IntelliJ, but obviously Spring Boot, Spring Framework works very well with NetBeans and with Eclipse. In fact, we even have Spring Tool Suite that is a build of Eclipse that just does a beautiful job. Integrates really well with cloud platforms, and it makes me cry the more I think about still using IntelliJ, although I love IntelliJ. So completely IDE agnostic. OK, so the first thing we want to start with is go to our application properties. Now, remember, we're going to be serving up our application properties for all of our microservices from this config server. But it can't really be turtles all the way down. You have to have an anchor point to start with. And the application properties provides you kind of a place to store sensible defaults. The one thing that we'll need, or a couple things that we'll need, is to provide a server port. I'm going to be running everything locally here today just to speed things along. So I'm going to run this on server port 8888. And then, of course, I have to provide a, let's see, Spring Cloud config server get URI. Because I'm going to be back-ending this to a Git repository. Now, you can use GitHub, GitLab, Bitbucket. You can use a local Git repo. You can use a Git repo on a network storage. That's fine. I'm going to recommend You don't point this to a directory on your MacBook, but that's what I'm doing for the demo. I do want to say that most of the time I try to follow best practices in terms of best coding practices. But there will be times for expedience that I will shortcut something, and I will identify that. I'll do my best to identify that so that you don't walk out and say, well, Mark said this is the way to do it, so it must be okay, right? So when I cut a corner, I try to identify that corner so you don't repeat this at home. So I'm going to point to dev, demos, YAML, microservices, services, config. Okay, I'm saving the front row on this time. I'm catching my own typos. Now, Spring Cloud Config Server can reference key value pairs. It can also reference YAML files, which gives you a little bit more structure. It doesn't care. It's entirely up to you, whatever your preference is. I like YAML, so I'm going to go with that. And then I go to my main application class, and I enable config server, and let's fire that up. And while that's starting, let's go out, and take a quick look at what this is. So let me blow that up a little bit. Okay, so this is what it looks like underneath my config server. Now, these are YAML files, and if you notice, I have one just called application.yaml. These are the properties that are served up to every microservice that contacts the config service and says, give me properties. So it gets these. Or you can specify based on a profile, so like application-cloud. So if you specify your profile for a microservice as cloud, it will get those properties instead. It will also get properties specific to that microservice, or that kind of microservice, based on its name. So if it identifies itself, for instance, as an auth service or an edge service, it will get those associated properties as well. Now, what happens if you have a conflict? More specific wins. So it's no problem, no conflict. It all gets sorted. So let's go out, actually really quickly, let's take a look, for instance, at edgeservice.yaml. And you can see that I have certain default or certain things in there. I'll go into more of this as we go along, but these are properties that are defined that are then served up by the config service. So let's go out and take a quick look. For instance, app master. Oh, yeah, it works. OK, that's always a plus. So these are properties that are served up to all microservices. Let's, for instance, look at the ones for edge service. And these are properties that are served up to any microservice that identifies itself as an edge service. So you see the application, the generic application properties, and then the more specific properties as well. So it's not terribly sexy. Sorry, it's not Spring Data. But it is very useful and essential for a microservices architecture. So let's go to the next step. We'll probably next go with a Eureka service. And for dependencies, we want to bring in the config client dependency so that we can use our config server to provide the keys and values for our Eureka service. And then, of course, we want to discovery. Nope, actually, that's not true. We don't want that. We want to bring in the dependency for our Eureka server. That's much better. That'll work much better. So let's save that down. And let's go back and open that. I normally take this kind of quickly, but it's a lot faster than normal even, so buckle up. Sorry for the fast treatment here. Okay, so let's maximize that. And the first thing that we're going to do is go to our, again, application.properties. But within the application initialization for a Spring Boot application, what happens? The application will look for application.properties. And if it finds that, it inserts those properties. It uses those properties when the application context is built. Excuse me. OK, what we want to do is kind of get out ahead of that in the bootstrap phase. And the easiest way to do that is just to simply rename our application.properties to something like bootstrap.properties. This is something that our application will look for and recognize as what it needs to read in and use as a reference to find, for instance, our config service. So I'm going to designate our Spring Cloud config URI. If you recall, we put that at localhost 8888. And I'm going to designate the Spring application name as Eureka service. So it identifies itself properly to our config service. And then I'm going to go to our main application class and annotate this as so, enable Eureka server, and we're up and running with that. So an incredible amount of code here so far, right? I mean, this is exhausting. You know, sometimes I speak at conferences where there's a mix, some Java, some of that other language that starts with Java, and other languages as well. And I sometimes ask, you know, who here has heard that Java is heavy on boilerplate? Oh, hands go up. It's like, okay, we're going to crush that myth today. And you all know better, but we're still going to crush it anyway. So we can see here that we're starting on port 8761. And that's because we serve that up, as you might imagine, cat Eureka service.yaml. We specify that in our properties that our config service serves up to Eureka. So Eureka allows for a service registry. It also gives us a really nice 8761 dashboard. And the dashboard doesn't do anything for our microservices, but it does something for us, for the meatware. And there's some good information out here, but kind of the key bits that we focus on are the replicas. Right now I'm running exactly one instance of this. You probably would not run a single instance of this in the real world, but again, for a demo, it's fine. And here we show what microservices and what instances of each microservice are registered with Eureka. We don't have any yet, so let's fix that. So let's start with creating a quote service. Now, does anybody here like movie quotes or pithy quotes of any kind? Oh, good. Okay, I have one other person. It always makes me a little sad when I'm the only person in the audience who likes movie quotes. Because I told you earlier, I have no life, and I recognize that, but it's really a painful reminder when everybody just looks at me like, seriously, that's the best you can do for hobbies? But okay. So I like movie quotes. So we're going to create a quote service that allows us to get a random quote when we query it, like a quote of the day, right? Does anybody even have a quote of the day app on their phone? Seriously? Okay, thank you. I have two. So clearly, again, have no life. So we're going to bring in the dependency for our config client. I also want to bring in the Eureka Discovery client, and then also Lombok, because I'm a lazy developer. Lazy is good. Why recreate the wheel, right? If somebody's done that for you, move on and create real business value. So let's do that. I'm also going to use JPA because we have to store and retrieve our quotes somehow. And as a colleague of mine likes to remind me, sometimes I make poor life choices. And I'm going to use H2 as the data store behind it. Obviously, any JPA data store will do, but H2 is very quick and easy to spin up, and quick right now is very important. I'm also going to bring in the dependency for REST repositories. This allows you to create Spring Data repositories and expose them as REST endpoints very quickly, very minimally coded, very nice. As well as being extensible. Again, it's that opinionated approach. It gets you started very quickly and lets you build out if you want to. Then I'm going to also include Stream Rabbit, because I'm probably overly optimistic, but why not? I'm going to also bring in the zipping client and also hate OAS. Now, I know some people pronounce that differently, but those people are wrong, okay? As somebody who has worked with a product called OAS in the past, I can tell you for sure, hate OAS is the correct pronunciation. I'm also going to bring in the dependency for the HAL browser, which gives us kind of some neat capabilities baked in, out of the box for free, for the cost of a free dependency. So I'm going to generate the project, and we'll go back, and let's see, we'll open that, and we'll open that, and bring that up. And then we're going to repeat a couple steps and launch in to creating our quote service, our awesome quote service that 3 of us will enjoy to no end. And the rest of you will, I don't know, do something better. I don't know. So I'm going to first go to my application properties. Oops, same thing. I'm going to rename that to bootstrap.properties. And then I'm going to open my bootstrap properties and provide a Spring application name. Again, this is called quote service. And I'm going to Spring Cloud Configure. And again, we are running that at http://localhost 8888, right? And then let's go to our main application class. And we'll enable discovery client. So that allows us to register our application, in this case our microservice, our quote service, with Eureka. And this is a working app. It just doesn't do anything yet, so it's kind of a lame working app. Even though you probably will think it's lame later, it's much less lame now. So am I close on time? Okay, all right, I'll keep rolling. If it's a question, hold it. If it's I'm out of time, I know, but I'll hurry. So, okay. So first we're going to start off, again, I'm using JPA, so I'm going to designate an entity. I'm going to create my domain model, so to speak. So I'm going to designate an entity. I'm going to use Lombok to do that. How am I doing on time? Okay, keep going. All right, good. All right, and then I'm going to do a couple of things. I'm going to specify a no-args constructor. Lombok will provide this for me. And then a few other niceties like a toString. And I'm going to create a class cleverly called quote, right? Surprise. I'm also going to designate an ID, member variable that corresponds with the ID field. And then I'm going to provide the little bit of nudge it needs to generate the value. H2, that's specific enough. MySQL, you have to provide a little bit more guidance, things like that. So I'm going to create an ID field called ID. Again, this is great stuff. And then I'm going to create another couple of fields here. For a quote, we want quote text, for instance, maybe, and quote source. And then because I kind of know what I want to do, I'm also going to create a 2-arg constructor. And that gets us our domain model. But now we need to provide some mechanism for creating a repository, Spring Data repository. So I'm going to create a quote repository, and I'm going to extend the CRUD repository for items of type quote and keys of type long. And I want to annotate that as a repository REST resource. So again, it will expose that as REST endpoints. And this gets us up and running, but it gives us no data. So we don't see what's going on yet, which is always a bad thing. Visibility is a good thing. So I'm going to create a command line runner bean, a bean that implements the command line runner interface, which is a functional interface, single abstract method, right? So I'm going to just call this command line runner. I'm going to, let's see, quote repository. I'm going to inject my quote repository, and I'm going to provide the Lambda implementation for my single abstract method. And because I'm not that fast a typist, I'm going to cheat and bring in some great quotes that is going to, they're going to inspire you, I hope. Okay, so let me find those quotes. Okay, so here we have some excellent, excellent quotes. I'm going to bring in the good movie quotes. And I know this is going to inspire. And because we have quotes, we assume we have quotes, but again, verification is a great thing, right? So I'm going to do a quote repository.findAll for each, and I'm going to system.out print line. Pringles. Okay, yeah, I'm hungry too. All right, so we'll fire that up and see what we have. Hopefully, we'll have a repository with a few entries, and we'll have some REST endpoints that we can exercise and test out and try and see what happens. So first, we'll take a look down here and see what happens. Hopefully, I don't have any typos, front row. No pressure. All right, so here we see we have some quotes. Aren't these great? Right? This is Spinal Tap. Anyone? The Big Lebowski? No? Man, this is really going to be a tough talk. I'm glad this is a short one. Okay, so let's pull it up and take a look. So we're going to go to localhost 8088. Does anyone recognize that number, by the way? Anybody? Bueller? 8088? Okay, well. Oh, thank you. Okay, I was going to say, clearly I'm the only old guy in the room. But really, that doesn't make me feel bad at all either. So the first thing I want to do is show you the HAL browser. Because right out of the box, the HAL browser allows you to navigate and exercise your endpoints. And as you can see, we have a collection endpoint for our quotes. Spring Data REST provides it for us without any effort on our part, without any additional code, which is really nice. We can do a GET. We can navigate into any specific quote. And within that particular one, we can do another GET, of course, and provides what you'd expect it to. You can do non-gets and test deletes or puts. So it gives you a lot of capabilities the HAL browser does just kind of out of the box. I always like to show that. It's a little extra nicety. But let's get back to business here. So let's go in first And let's look at our quotes. And this is a HateOAS formatted JSON response. I don't have time to get into all this today, but again, this gives you application navigability based on context. What should be exposed at any given point is here, and you can build that and navigate in. Right now, you have the capability exposed for you to provide all quotes or a particular quote. But that's kind of a lame quote application, right? I mean, to go to the same quote every day, that's not very inspiring. So we need to provide some mechanism for randomness. So let's randomize this. So let's see. Okay, I'm going to have to get really fast and wrap this up really quickly. So let's throw some goodness in here. We're going to create a REST controller. And we'll call this, again, cleverly enough, quote, controller. And let's see, first we'll inject final, quote, repository. And let's create that. And now let's do a get mapping /random. Okay, so that'll be our random endpoint. And we're going to return a quote, get random quote. And let's see, how are we going to do this? Well, we're going to start with our quote repository. And here's where we kind of hit a little bit of a stumbling block, right? Because Spring Data gives us a lot of capabilities, as you can see, just baked in for free. But we want to provide a little bit more specificity. We want to have a randomizer, and it doesn't do that. I mean, it can't read our minds. So wouldn't it be cool if we could define something like a query using SQL or JPQL, something along the lines of select Q from quote, Q, whoops, caps lock, quote, Q order by brand. Okay, not overly elegant, but it should work. List, listy, all right, quote, list of type quotes. Boom, yep, that's fine. Get quotes, random order. Okay, so that gives us at least what should be enough capabilities. So let's do get quotes, random order. Get, we'll pull back the first one, return that, and we're in business. Hopefully that'll work. Now, since I am short on time, we're going to assume that'll work. If not, we'll come back to that, and the front row will be in trouble. But let's go ahead and create our edge service that allows us to maybe show some of the capabilities of Hystrix and Ribbon and Zool and the fun stuff there. So let's see. Let's go back here, and let's create an edge service. I'm going to remove some of the dependencies here that we don't need. We're not going to be storing things directly from our edge service. That's why we have our backing service, our quote service. So I'm going to remove JPA and H2. I'm going to remove the REST repositories. I'm going to go ahead and pull these two off here as well. And now I'm going to add a few things. One, we want to define a web API. And we had that as a subdependency, a nested dependency from our REST repositories. We don't have that now, so let's add it in. Let's see, I'm going to add in actuator, because that is really cool. Again, very neat capability. You saw a little bit of yesterday. I'm going to show you a little bit more, hopefully. And we want to bring in Hystrix, Ribbon, and Zool. Okay, so that should get us what we need to get rolling. Let's save that. And let's go back and open that up. Boom, okay. So maximize. What's my drop dead time? How much more can I go without inconveniencing the next person? 5 minutes. We can do this. Okay, no pressure at all. Okay, so first we're going to go to our application properties. We're going to once again rename that to bootstrap.properties, open bootstrap. We're going to provide our Spring Cloud configuration, http://localhost 8888, Spring application name. Again, this is edge service. And because I am a crazy optimist, I'm going to go ahead and add in another capability. This is a non-best practice. Please do not disable management security for your management endpoints. I'm doing it for expedience, okay? Do not do this at home. Actually keep security, enable security, but I don't want to detract from the actual other stuff that we're trying to discuss. So now I want to enable Zool proxy. You're probably wondering why I didn't do an enable discovery client, because don't we want to register this with Eureka? Won't we want this Eureka where? This is a meta annotation. Enable Zool proxy. The assumption is you're going to want Zool, the Zool proxy, to be Eureka aware, right? So you can see here it has enable discovery client built in, as well as circuit breaker. So it gives you the capabilities that you need in a very clean and simple single annotation. Very nice. So I'm going to, once again, I'm going to define no args constructor, all args constructor, toString, class, quote, private, long ID, private, string, text, source. Okay, so we have our domain model. I'm going to create a REST controller. We'll call it again, class, quote, controller. Okay, so let's create a get mapping. Yes? Okay. Actually, you know what? I'm not sure I'm going to get through this, so let's go ahead and just be crazy optimistic here. I'm going to do a quote orama endpoint, because that sounds cool, right? Public quote, get random quote. Okay. Now, to bring in our capabilities of our ribbon client-side load balancer, I'm going to create a load balanced bean. And we're going to expose or provide a REST operations right to the interface, right? REST operations, return new REST template. Okay. Now, I'm going to leverage that. And again, this is probably not your best practice, but I think it's instructive so you can see kind of what Zool does. So I'm going to return. Oh, and actually, I want to do this. I'll, again, shortcut, AutoWire in, REST template, return REST template, get for object, yep, http:// quote random, right? Quote.class, sweet, okay. So, really quickly, I'm going to kind of condense several things that I normally like to break out and show when time is a bit of a luxury, and we'll get there. So the first thing I'm going to show you is 8086. Again, does anyone recognize that? Anyone? All right, excellent. Oh, this is great. If I only had a free T-shirt to give you, I would. Maybe there's an extra one in the back. I don't know. But my two quote fiends, excellent. So.
REST template. Error on REST template.
Okay, so what did I miss front row here? Oh, yeah. REST operations. That's fine. Okay, so let's roll with that. Okay, so to give you a little bit of a heads up, what's going to happen, what should happen, is now this should work. Come on. Oh, yes, that's much happier. Okay, so if you look here at our quote service and our edge service, you can see that everything's the same. It's just some URI rewriting, right? This is what's called a microproxy. And the fact that we have routes defined, whoops, yeah, here we go, Zool routes defined in our config properties allows us to define certain routes. You can see here that it's also Eureka enabled. So we don't have to have a valid URI, for instance, here. You can see here we don't have a specific URI. It's Eureka enabled. It does a lookup for us. So if we go back here, we also see that anything that from our edge service that we access via the path QS, we'll do a straight pass-through with the URI rewriting. Very nice. I also have defined another path here. I just call it demo, but you can call it, again, whatever you'd like. You can do forwarding to local or remote URIs. So anything that starts with quote should forward to our local URI. So let me go back to that. Boom. So we first start with Quoteorama, and we see that that works. And then we go up here, and we go to quote. And of course, that works as well. So that's a little bit of a manual way of showing you what happens with Zool, what Zool provides automatically behind the scenes. But I like to do that because, again, it kind of ties it all together nicely. Did not get to Hystrix. Sorry. Did not get to some of the other stuff like asynchronous messaging, Spring Cloud Stream, but very happy to talk about that at length offline later on. I think we covered at least the high points of Spring Cloud and all of the key capabilities that you kind of need to enable your microservices to interact and to enable us to understand and manage our microservices architecture. So, I killed the mirroring. Let's go back to here. And just one more thing. So, in summary, microservices can be hard, but they don't have to be. Lean heavily on enablers, especially the enablers that are provided for you. Don't reinvent the wheel. Build for speed and resilience. Everybody always says, well, hey, we're not Netflix. You know what? Adrian Cockcroft said this before. Where do you think they got their engineers? From everybody else. This is not something that you can't do wherever you are, in whatever environment you're in. So go out, do it, use the tools at your disposal, and thanks so much for coming.
Thank you, Mark.